Let us continue. So here I will write what do we know in this problem. So we know that rho, the radius of curvature rho, is equal to 90. We know that AT is equal to 2.1. We know that A total acceleration is equal to 2.4. Okay, and we need to find what is the time needed, what is the time t needed to reach this acceleration. Okay, so first, if we know at and a, what can we get? If I know the magnitude of at and the magnitude of a, what can I get?
an.
And from an, what can I deduce?
V squared.
Yes, exactly, v squared. Here, they asked for the time before v squared. This is why we should express v function of t. Okay, so let us do it together. So first, a squared, the total acceleration squared, is equal to an squared plus at squared. But since, so now I will replace directly an by its value and a and at. A, it's 2.4, so it's 2.4 squared equals to an. I will replace it by v squared over rho, and rho is given, it's 90. The whole term to the square plus at, which is 2.1 squared. Now, since they didn't ask first for the speed, they asked first for the time, we should express v function of time and replace it in this equation. What is v function of time here? How to get v function of time? They gave us at is 2.1, which is a constant. They said it's constant, okay? And at represents what? It's dv over dt. So now if I integrate, or directly I can use the equation for constant acceleration. What can I say? I can say that v is equal to 2.1, which is the constant acceleration, tangential acceleration, plus v0. But from the given, they said that the car is starting from rest. So v0 is 0, and I have that v is equal to 2.1 t. So now, all I have to do, I replace in this equation v by its value, function of time. So I will put, instead of v here, I will put 2.1 t. Okay? And in this case, in this equation, what will be the only unknown? The only unknown will be the time. So I get the time t. Okay? And then once I get t, I can calculate the speed, because after I know the time, I can replace back into v. V is equal to 2.1 t. So I calculate the speed. Okay? So always, sometimes you might need to combine several formulas in the same problem. Any question about this? So now another problem. The boxes travels along the industrial conveyor. If a box starts from rest at A and increases its speed such that at is 0.2 t, so here pay attention, the tangential acceleration is not constant, it's a function of time. So you cannot use the formulas of constant acceleration. Determine the magnitude of its acceleration when it will reach point B. So here, this is the figure. They gave us the following figure. I'm going from A to B, but as you can see, my path first is a rectilinear path. So first I move on a straight line for a distance of 3 meters. Then from this point to B, I move along a curve, which is a circular path. So I move along a circular path. Okay. What they want me to find is the, let me go back to the given. I think the total time maybe. No, they want me to find what is the magnitude of its acceleration when it will reach point B. So I want to find what is the acceleration of my system when I reach B. So this is a question. I need acceleration A at B. Okay. So here, to find the acceleration at B, B is on a curve. So I should find two things. I should find AT and I should find AM. So to complete my problem, I should calculate A tangential and A normal. Okay. So here I will put it. I want to find what is AB, what is acceleration of point B along UT, and what is acceleration of B along UM. First, to find, if I want to find AB normal, what is the formula? What is the formula for AB normal? It is VB squared over the radius of curvature. The radius of curvature is the radius at B, but you know that it's a circle. Because it's a circle, the radius of curvature is equal to the radius, which is 2. So I know that AB normal is VB squared over 2. Okay. Now I still need to find what is the velocity at B. Who will tell me how to find the velocity at B? What should I do? Look, they gave me AT, okay? They gave me AT function of time. AT is 0.2t. And I know that I can relate AT to velocity because AT is dv by dt, okay? So since I have the tangential acceleration function of time, if I want to find my velocity, I can integrate. So here I will do separation of variables. I will take dt to the other side. So I get that dv equal to 0.2 t dt. And now I will integrate. I know that I'm starting from rest. So for t equals 0, v equals to 0. Okay. So now I got v as a function of time. But still, it's not enough. I need to find what is the time needed to reach point B. Who will tell me which information I will use to get the time at B? What did they give me in the figure? Look, in the figure, you know the distance of displacement. Because first, when you go over the straight line, what was the distance displaced? 3 meters. Then, when you go over your curved path, you can calculate the total distance because it's an arc of circle. If you have an arc of circle, how you calculate its length? It corresponds to the radius times the angle. So you can say that the distance traveled from here to here is simply pi over 2, which is the angle, pi over 2 times the radius, which is 2, so it's equal to pi. So in total, what is your total as total travel is equal to 3 plus pi, okay? But you know that even if first we have rectilinear, then curvilinear, everywhere AT is the same because they didn't tell us that AT is changing during the path. So I can consider that it is one path with same formula of AT. This is why when I get V function of time, I can say that V is what? V is ds over dt. Okay, so I can now find S function of time by simply doing separation of variables. Okay, so now if I separate variables, I can get the expression of S. Okay, so V is equal to ds by dt. And I know that at t equals 0, I start from s equal to 0. So when I integrate here, I can integrate directly from 0 to tb. If I integrate here from 0 to tb, I should integrate s from 0 to s of b. And we have calculated together what is s of b. S of b is s total, which is 3 plus pi, 6.142. So now, if I integrate from 0 to s of b, the only unknown in my equation will be tb. I can get the time needed to reach point b. Once I get the time, I am done. Why? Because I have already expressed v function of time. So to calculate vb, all I have to do, I replace tb in my formula here. I calculate then vb. So now I know the velocity at b, so I can get an. I still need to find at, okay? But at is function of time, because if you go back to your given, at is 0.2t. So once you have tb, all you have to do is to say that a tangential at b, so at at point b is simply at at b is simply 0.2 times tb, okay? And in this way, we are done, because we have found an and we have found at. So to find the magnitude of acceleration, all we have to do is radical an squared plus at squared, okay? So here we found from s of b, we were able to calculate the time. Then here, all we have to do now is to replace the time to get AB tangential, and then we replace VB, and also we replace the time to get VB. And once we get VB, we can calculate AN. And finally, the magnitude of acceleration is simply radical of AN squared plus AT squared. And this is the problem, okay? Any question on this? So we are done for today. Just guys, one thing, Monday is a holiday. So they said in the email that we can do makeup on next Saturday. But next Saturday, I have an exam for another section during your class. Can we do it tomorrow? Do you have a problem to do a makeup session tomorrow? In this way, we can finish this chapter.
Doctor, you have exams. Can we do it next week?
Yeah.
We can
Yes.
agree on a time, like as you like. يعني مش ضروري يكون at
But
8.
you have exams. Can we do it next week, not this weekend?
We do it
Please.
next week, but مش at 8 because I have another exam. So we can agree on a date for next Saturday.
Yes, please.
Okay, that's fine. Okay.
Doctor,
Yes.
another solution. You can record the session and send it to us, and we can watch it whenever we want throughout the week. And then if you have questions, we ask you on the group WhatsApp.
If we can do it live, it will be better. So you can ask directly. If not, yes, I can record it and send it to you. But I prefer, because you ask directly questions. So I don't mind, but it's better for you to have it live. Okay.
Okay, doctor.
Okay. Yeah. So see you on Wednesdays. Okay. Bye bye.
Thank you, doctor.
Thank you, Doctor. Bye.